Hi, welcome back. This is 0955. We're going to work today with solving linear inequalities. In 8.2, we saw a little bit of this stuff, so this may seem like a bit of a repeat, but just in the beginning. Okay, it's going to kind of go in a bit of a different direction. Anyways, looking over there at the problem number 1, we want to describe the inequality using the number line. Okay, so describe the inequality x greater than -6 using a number line. So what does this mean? This means any value x that's greater than -6. So let's draw a number line. Here's -6. We can put some other values around there. Okay, and anything greater than -6 means it's to the right of -6. So it's going to be this stuff over here. And it's a greater than symbol, so we don't include -6. If it was greater than or equal to, in other words, if it had a line underneath the inequality, we would include it, but we don't include it. So we're going to use an open parentheses to indicate that we're not including -6, but anything else in that shaded region will work in that inequality. Okay, those are all the numbers greater than -6. Okay, so you just go over and click on the appropriate answer. That's not it. There it is. And go on to your next question. Okay, so here's one with a greater than or equal to symbol. That means you do include the end point. So here we have x greater than or equal to -4. So again, just like above, I'm going to graph -4 on the number line, and then maybe put a couple points around it. -5, -3. And this says all values x that are greater than or equal to -4. So anything greater than -4 is going to be to the right of it, so you can shade all that in. And this time, because the line is underneath it, we can include -4. Okay. Greater than or equal to -4, and -4 is equal to -4, so we can include that. So it looks like it's B. Okay, this time they just have a decimal involved. Not a big deal. You just graph the decimal. So I guess it's problem 4 actually. This must have been problem 3. So x less than or equal to 4.5. So go to our number line. Here's 4, here's 5, 6, 3. Anything less than or equal to 4.5. So here's about 4.5, and then we want anything below it to the left, right? So all of that material. We'll use a closed bracket to indicate we can include 4.5, and then we'll go to our answer. It's like B. Okay, now we have a compound inequality, and we've seen this before in 8.2. This just means all numbers in between -3 and 6. So we have the inequality -3 less than x less than or equal to 6. So go to our number line. Here's -3. We put some other numbers in there. 2, 1, 0. 1, 2, 3, 4, 5, 6. Let's not put them all in, I'll just give an idea. So it's anything in between. Let's get a red. -3 and 6. Okay. We don't include -3. It's all numbers greater than -3. So -3 is not greater than -3, so we don't include it. But then we can go all the way up to and including 6. So we'll put a square bracket on that. And that looks like B. Okay. Same kind of problem here. We use open parentheses because neither inequality has a line underneath, so both will be open parentheses. It looks like it's E. Now they want us to, what do they want us to do? Okay, turn the inequality into interval notation. Okay, so it's number 7. And the way I do this is just to graph it, and then kind of the interval notation is on the number line. You can kind of see it there. So we have x less than or equal to 7. So on the number line, here is 7. You put some extra points in there if you want. It's anything less than or equal to, so to the left of 7. And we use square bracket. And then you could kind of have the interval notation right there. So if this side is negative infinity, I'm going to be going from negative infinity all the way up to 7. Okay. With negative infinity, you always use an open parentheses, and then you borrow the parentheses type from the number line. So if we include, we use a square bracket, and you can kind of see that all you're doing is kind of borrowing the notation from what you've already done. Okay. So here, the interval notation, negative backslash INF, all the way up to 7 with a bracket. Then we already have our graph, so just pick on the correct one and then move on. Okay, this is the same problem here. Now we have a greater than symbol, so problem 8. X greater than 7/3. So 7/3 is 2 point something. Let's go to our number line. So let's put 7/3 about right here. And, whoops, I don't know what happened there, technical glitch. Okay, so let's put 7/3 about right here. And that's everything greater than that. So it's shading into the right. We don't include 7/3, so we have an open parentheses. And then you're going all the way to positive infinity. So you're going from 7/3, but not including, so you use open parentheses, and then all the way to infinity. And you always use a parentheses with the infinity symbols. Okay? So parentheses, 7/3, all the way to backslash INF. Oops, I lost a parentheses there. And I put it in wrong, so it's 7, not 97. Whoop, and I forgot the comma. That's just like 3 or 4 errors bundled. Okay, there's more. Yeah, then identify the number line, graph. Okay, more of the same stuff, so I think we can leave that one to you. Okay, so now finally after we get through this, we're into kind of the objective for this section. We want to solve what are called linear inequalities. Okay, and it's very similar to solving equations. You're going to use the same properties to solve these, with one small exception we'll see along the way. All right, so problem 11, x minus 6 greater than 2. So back before, so now it's kind of with an inequality. Before, though, the way we would solve this, x minus 6 equals 2, is kind of how we're going to solve the inequality problem. So you just add 6 to both sides, you get x equals 8. That would be your answer. Now you have an inequality. So you're going to, anyways, you do the same thing as what we did before, add 6 to both sides, get x all by itself. And you'll have x greater than 8. Okay. For our answer, we can't just leave it like this, though. They want the interval notation, and if possible, graph the solution on a number line. I mean, not if possible, but usually they ask for it. In this problem, they ask you to graph the solution on the number line. Yeah. So first off, they want the interval notation. Let's just graph it first, and then we'll get the interval notation from the graph. So here's 8. They want everything greater than 8, so that's all this stuff to infinity. And we're not including 8 because there's no line underneath the inequality. So borrowing the notation, it's 8, comma, all the way to infinity. Always use parentheses when infinity. And that goes in the first slot here, comma, backslash inf, parentheses. And then I think they want you to graph it. Okay, so yeah, looks like B. A. Same thing. So you know, it's just exactly what we did with equations, but now there's that inequality symbol, and it kind of changes your answer at the end. Okay. Let's try. Well, let's try one more of these. Let's try 13, and then we'll go on to 14. So y minus 11 less than 0. So again, you're just isolating y. So I add 11 to both sides. I'll have y less than 11. And then on the number line, here's 11. I'm not including it, but it's everything to the left of it, all the way down to negative infinity. Open parentheses because I don't include it. So if you're reading on the number line from left to right, it's starting down there at negative infinity and going all the way up to 11, but not including 11. Okay. So negative backslash inf, comma, 11, not including 11. Okay. So negative infinity to 11. Okay, so now question 14 is more complicated. We have more stuff floating about, but it's the same as solving equations like we did when we first started the class. So I'm going to collect all the variable terms on one side. So 6x minus 5x is 1x. And then I'm going to move the constants to the other side. So subtract 3. And I get x less than or equal to 6. Okay, then I'll go to my number line. Here's 6. It's everything less than or equal to 6. So it's all this stuff down the negative infinity. And this time I include 6 in my solution set. So I use a bracket. So it's going to go from negative infinity all the way up to 6. Negative infinity, oops, I'm going to go backslash enough all the way up to 6 with a bracket. Where are we? Negative infinity to 6. Oops. Okay, and then more of the same. A little bit of the same thing there. Ooh, fraction problem. Let's try fraction problems. 17, x minus 1/7 greater than or equal to 1/2. So add 1/7 to both sides. So get x greater than or equal to 1/2 plus 1/7. Need a common denominator here, so I'm going to multiply the first guy by 7, top and bottom. Second guy by 2, top and bottom. So I have x greater than or equal to 7 over 14 plus 2 all over 14. In other words, I need x greater than or equal to 9 all over 14. Okay, so here's my number line. 0, 1, 9/14 is probably about right here. So it's everything beyond that. So it's all this stuff all the way up to infinity. And we include it, so you use a square bracket. So you're going to borrow the notation straight from the number line, square bracket 9/14 all the way up to infinity. Always use open parentheses with the infinity symbol. 14 backslash inf. That should do it for that. Okay, great. Number line. Like that. Okay, more fractions, so we can handle that. And more stuff. Oh, so now they're moving on to the multiplication property, which is pretty simple. Multiply or divide both sides. This is where you have to be a little careful, though. Okay, so if you multiply or divide both sides by a negative, it changes the direction of the inequality. Okay. And everything else exactly the same as how we solve equations. It's just this is kind of the catch. Okay. Let me make sure I'm recording. Yeah. Okay. Number 20 is not. This doesn't happen. So number 20, we have 1/2 x greater than 9. So I'm multiplying both sides by positive 2. And you'll end up with x greater than 18. So we're good there. So here's our number line. Anything above 18 all the way to infinity, open parentheses. Right. Whoops. Yeah, it's open parentheses. Okay, so 18 all the way backslash inf. There we go. And the number line. Okay, same deal here, just multiply both sides by 4. Here, now you're dividing instead of multiplying, so you divide both sides by 5. Divide both sides by 3. Okay, so let's compare and contrast number 23 to number 24. So number 23, we have 3x greater than or equal to negative 15. And to solve for x, you divide both sides by 3. Right? So you end up with x greater than or equal to negative 5 on my number line. Here's negative 5. I include negative 5, and then it's everything above it, all the way up to infinity. So my answer would be negative 5 to infinity. Okay, negative 5, comma, backslash inf, in parentheses. And then the number line. Okay, great. The next one is different though. So why is it different? It's because of the star thing I wrote. In this problem you're going to see, we're going to divide both sides by a negative, and that changes things. Okay. So in this case, we have negative 3x greater than 12. So instead of dividing by positive 3, I'm dividing by negative 3, and that's the catch. So as soon as you do that, it changes the direction of the inequality. So right now it's greater than. By dividing by a negative, it changes to a less than. Okay? And that's really the only kind of new part you have to remember. But anyways, you could do your number line. Here's negative 4. It's everything less than negative 4 down to negative infinity. You don't include negative 4. So it's going to go negative infinity, the negative 4, open parentheses, and do it to backslash inf, parentheses, 2 parentheses for some reason. Oh, well, I reversed them, sorry. So negative backslash inf all the way up to negative 4. I'll check your answer. And then negative infinity to negative 4. Answer, yay. Okay, yeah, and so on and so forth. So this one, you're going to divide by negative 6. You've got to change the direction of the inequality. Again, here, you divide by negative 12. You have to change the direction of the inequality. Here, you're dividing by negative 4. We might as well do 1. And I hit the wrong button, as usual. Okay, so number 27. Negative 4y less than or equal to 1/4. So I'm dividing both sides by negative 4. To avoid dividing a fraction by something, what I'm going to do instead is just multiply both sides by negative 1/4. Okay, that's the same thing as dividing by negative 4. So on the left, that will just give me y, and because I multiply by a negative, I have to change the direction of the inequality. And on the right, I'll have negative 1. 1 times 1 is 1, and then 4 times 4, 16. Then I can do my number line. So I have negative 1/16, close bracket, and it's everything above that, all the way to positive infinity. So borrowing the notation, negative 1/16 to infinity, open parentheses. And so square bracket, negative 1/16 to infinitar backslash infinitar parentheses. And then graph it, so it looks like A. Yay. All right, great. Again here, you multiply both sides by -1, so that'll change the inequality. And now we're combining both the addition and the multiplication properties to solve inequalities. Let's try number 30. So I have 4x plus 5 greater than 29. So first move the 5 over. 4x greater than 24, and then divide both sides by 4. It's a positive number, so it doesn't change the inequality at all. That will just be x greater than 6. So here's 6, and it's all numbers greater than 6, but not including 6. So it's going to go from 6 all the way up to infinity, open parentheses, backslash inf. Okay, so 6 to infinity, that's e. 31, looks like you're going to have to divide by a negative. So 7 minus 5x is less than or equal to 27. So first I'm going to move the 7. So I have negative 5x less than or equal to 20. Then I'm going to divide both sides by negative 5. So you have x that changes the direction of the inequality, and then negative 4. Okay. So on my number line, it's everything greater than or equal to negative 4. So that'll be everything to the right of negative 4, all the way up to infinity. Okay. So the solution set, bracket, negative 4, comma, backslash inf, and parentheses, and then graph it, 4 to infinity, yay. Okay, so again, it's nothing new. The big difference is, if you multiply or divide by a negative, you have to change the direction of the inequality. Okay, and they get harder and harder, so then you start having issues with, you got to simplify the heck out of it before you start. So let's see if we can find one of those. So like 36, simplify both sides first, right? So simplifying usually means combining like terms or distribution. So here is a distribution, so we'll have 6y minus 4 greater than 8. Then we just add 4 to both sides. So I have 6y greater than 12. Divide by 6. 6 is positive, so I don't have to worry about any changes. And with y greater than 2. So here's 2. It's everything greater than 2 all the way up to infinity, but not including 2. So you show that with an open parentheses. And there's my solution, my interval of answers. So it's different than the solving linear equations, solving equations. Equations will give you like maybe 1 or 2 answers, or maybe infinite solutions, right? But here we have intervals for our answers. So it's a little bit different type of answer. You're going to see like no solution, infinite solution problems again. Let's see if we can find one of those. Here's a fraction problem. So this is one of those. Okay, so 41, we have 3x minus 3 less than 3 times x minus 5. So 3x minus 3, simplifying on the right by distribution, 3x minus 15. And then you try to collect all your variables on one side. And what happens is the variables cancel out, right? So you're left with a statement. Is this true or false? Is negative 3 less than negative 15? That's false. Negative 3 is to the right of negative 15. And when that occurs, then, just like with equations, you'll say no solutions. Or as they put it, you see part B, the solution set is the null symbol, the empty set. So that's basically just the curly brackets with nothing in it. but there's another way of writing that. It's the null symbol, like that. Okay. But on my test, you could just write no solutions. So another no solution problem. This is another no solution. No solution. Oh, sorry, you kind of have to investigate. You can't just look at it and say, well, it doesn't work. So let's try. I think actually 44 is infinite solutions. Sorry. So I was just ripping through blindly, not even to. So going back, I should go back to redo myself. This one is actually infinite solutions. 42 will be infinite. But let's look at 44 so we can kind of figure out why is that the case. Right, so here's 44. 4 times x plus 6. Is that greater than 4x plus 5? Okay, so distribute on the left. I get 4x plus 24. Is that greater than 4x plus 5? I'm going to try to collect my variables. Okay, and the variables cancel out, and I'm left with a statement. So to see if it's infinite solutions, if that's true, it will be infinite solutions. So is 24 greater than 5? That's true. So that tells me I have infinite solutions. To write that in interval notation, it's the entire number line, right? So far the graph it's just literally everything on the line going from negative infinity to infinity. So to put that interval notation, you just put negative infinity on the left and then positive infinity on the right. And you always use open parentheses with the infinity symbols. Okay, so you kind of have to go through, and it's not as simple as the infinite solution cases with equations. So what you have to do is kind of look at them to see if both sides are the same, right? So just because both sides aren't the same here, it doesn't mean that it's no solution. So you really have to get that inequality, and then you can see whether it's true or false, and then make your conclusion. Okay. Okay. Let's see, we probably have some story problems here. The bar graph shown is the percentage college freshmen with average grade of C in high school. The data displayed by the bar graph can be described by the mathematical model. So it's problem 46. P equals negative 0.5x plus 21, where x is the number of years after 1980. And P is a percent of college freshmen with an average grade of C. Okay. According to the formula in 2010, what percent of college freshmen had an average grade of C in high school? Okay, so they want to know basically what is P when X is, oops, 30, right? 30 years after 1980 is 2010. So you just plug 30 in for the P equation and for X. Negative 0.5 times 30 plus 21. And go to my calculator, negative 0.5, excuse me, times 30 plus 21, and then push enter, and 6. So 6% of, supposedly in 2010, only 6% of college freshmen will have a C average. And how does that compare to the bar graph? So the bar graph, if you look at it, 3, 4, 5, maybe it's about the same. I'm kind of guessing, but I'll just see. Yeah, they're the same. According to the formula, how many years after 1980 will no more than 1.5% of freshmen have an average grade of C in high school? Okay, so this is part A. Part B is actually an inequality. So they're having you set up an inequality. They're asking you to take when is the percent? So the percent formula is 0.5x plus 21. When will it be no more than 1.5%. So the way you interpret that in English is, or in math at least, has to be less than or equal to 1.5, because 1.5 would be okay, right? It says no more than 1.5. 1.6 is bad, but 1.5%, it fulfills their criteria. And then all we have to do is solve this inequality. So I'm going to move the 21 over. So negative 0.5x less than, sorry, my brain, I don't trust my brain to do math right now. There's too much going on in my life. 19.5, negative 19.5, and then I have to divide both sides by negative 0.5. Negative 19.5 divided by negative 0.5. That's going to give me 39. And I divided by a negative, so it's going to change the direction of the inequality. And then we have to interpret it. So x values represent years after 1980. So anyways, on the number line, here's 39. It's anything greater than or equal to 39 years after 1980. So starting in the year 2019 and then beyond, no more than 1.5% of these people are going to have C's as averages. So maybe it's a statement about grade inflation. Okay. So anyways, in 39 years, oops, 39. Well, it's not 1980 anymore, but 39 years, according to the model, 39 years after 1980, the people, only 1.5% of the people will have C averages, and that's from 2019 onwards. So for these problems, you want to be a little bit sensitive to whether or not you're using greater than or equal to, or just a strict greater than inequality. Let's look at 47. So 47 is a great question because this type of inequality is how you could figure out your grades and stuff like that here in school. Anyways, 47, on 2 examinations, you have grades of 84 and 89. Then there's this optional final examination, which counts as another grade. So you could just say, maybe call that X. You decide to take the final in order to get a course grade of A, meaning the final average has to be at least 80. What do you have to get on the final to earn an A in the course? So you want your average of grades, 84 plus 89 plus X, divided by 3, because there's 3 test grades, so you just divide that by 3. That gives you your average. And you, for an A, you want that to be greater than or equal to a 90, right? If you said just greater than 90, that wouldn't include getting a 90, and that would not be good. So you want greater than or equal to, because either way, if you get a 91, 92, 93, 94, those are all A's, but also if you get a 90, that's also an A. Okay, so first you're going to simplify the fraction. Fractions are like in PEMDAS, it says parentheses, but they also include fractions. So you simplify the top, and then you simplify the bottom. And the top, you're going 89 plus 84, 173. So 173 plus X all over 3. That would be greater than or equal to 90. That's about all I can do there. And then I'm going to multiply both sides by 3. Right? So 3 over 3 is the same as 1 over 1 there. So the 3's cancel, and you just have 173 plus X. On the right, you'll have 270. And then we're going to move the 173. Okay? And students ask me to figure out their grades all the time. This is the kind of calculations I do as a teacher. So if you want to become a teacher, you should be able to do this stuff. Minus 173. So I'm going to need to cut over here. That'll be 10, 7. So I'm going to borrow another one from there. C9, 97. So it looks like you got to get a 97 or above. Okay, so at least a 97. Excellent. Part B, you will lose. Okay, so by taking the final, if you do poorly, you may risk the B that you have in the course based on the final exam. If your final average is less than 80, you will lose your B in the course. So describe the grades that cause this to happen. So you just take the original inequality and kind of edit it a little bit. Okay, so I'm just going to rewrite it down here. And so I have 84 plus 89 plus x over 3. And I want to see where that cutoff place is. So if this average is less than 80, I'll lose my B. Okay. So notice it doesn't include 80. If it was less than or equal to, it would include 80, but that wouldn't be true because if you get an 80 average, you still have a B. This is just less than 80. Okay. You could also write less than or equal to 79. Okay, but that wouldn't include 79.9, right? So you want to keep it as a less than 80. So I guess you really wouldn't want to write it as less than or equal to 79. That wouldn't be good. This is the way to go. Okay, this is the setup. Okay, once you get it set up like that, and then it's just business as usual, just like before. You're going to simplify the numerator here. Then you're going to multiply both sides by 3. On the left, the 3's will cancel. On the right, you'll have 240. And then you're going to subtract 173 from both sides. And if you get a less than a 67, you'll lose your grade. If you get a 67, you'll be okay, but less than that, 66.999, you're done. Okay, you lost your B. You're not done, but you know. So less than a 67. Okay. All right. Then we have some problems that are good. If you have a certain amount to spend, you want to know how far you can drive if you rent a car, that kind of idea. So here, a car can be rented for $85 down for the week, plus a variable rate of 55 cents per mile. How many miles can you drive if you have at most $250 to spend? Okay, so you set it up like an inequality. The kind of equation for the cost is going to be that 55 cents per mile, so we'll let X be the number of miles, and then this $85 down price. Okay. And this needs to be less than or equal to whatever amount of money you have. So you have a 250 bones, you got to make it less than or equal to that. Okay, so I'm going to subtract 85 from both sides. And I get 0.55x less than or equal to 165. Then I'm going to divide both sides by 0.55. And I get 300. So you need to keep the miles driven to less than or equal to 300 miles. Okay? There's my answer. So at most you could drive 300 miles in 1 week. Another kind of problem, this was kind of a scary one in my opinion. You have an elevator and you're trying to max it out. So if you ever go on elevators, they always have this maximum capacity, like 400 pounds, and you start looking around it. Oh no, is there 400 pounds of people on this elevator? That's always scary, but this is on a construction site, maybe even scarier still, and you're taking people up and down. You're also carrying bags of cement, apparently. So an elevator at a construction site has a maximum capacity of 2,190 pounds. The elevator operator weighs 240 pounds. And then the cement bags weigh 75 pounds. So how many cement bags can you put on the elevator? So it's a little bit like the driving problem from before. You have this kind of down payment for the guy that's running the elevator up and down. That's 240 pounds automatically. And then you have a variable rate based on the number of bags of cement. So if you have like 1 bag of cement, it'll weigh 75 pounds. 2 bags of cement, you just multiply it by 2, so it's like 150, etc. And we need this to be less than or equal to 2190. You know, preferably a lot less than 2190, but I don't know how those construction guys are. They live for excitement or something. I don't know. It's probably, they have to be very, very careful. It's probably high stress. But anyways, I'm going to move the 240 over 0, 5, 1, 8, 9, and then so it looks like 19, less than or equal to 1950. Then I'm going to divide both sides by 75. 1950. By 75. One of my friends was really into construction. And then later in life, he went back to school, got his engineering degree. Just like he wanted to move up, and you know, his back was killing him, so he wanted to work in more of a management capacity. So it's a good way to start, especially if you're interested in physics and stuff like that. You'll have a really good understanding. Maybe not, you won't have the math background, but you'll have a great understanding of kind of how, you know, things balance and just ideas like that. And then later you go to school and they make it more rigorous by kind of including the mathematics of it. So it's a good way to get a start, but it can be dangerous. So anyways, it looks like at most you can have 26 bags of cement on there. I wouldn't push it though, right? Okay, so I think that'll do it. And as usual, thank you for watching. I hope that helps, and have a good time studying. Okay.